Hello friends, welcome back. Today we'll try to solve some numerical problems related to Thevenin's theorem. Okay, in the one of the lectures in my channel BEC01, I tried to discuss about the Thevenin's theorem. Okay, I derived Thevenin's equivalent voltage and Thevenin's equivalent resistance, and replaced the original circuit with the Thevenin's equivalent circuit. Okay, in this video we will try to solve one simple problem to have better understanding of this concept, and at the same time I will use LTSpice to verify the result, the calculated result and the simulated result. Oftentimes simulation programs are of great help, okay, especially in designing some circuit, whether it is big or small. Okay, before prototyping we can simulate our circuit. Okay, it saves our time and money. Okay, so let's take the a simple circuit. Suppose we have an input voltage of 12 volt, okay, and some resistive network as shown here, R2 and R3. Let us put some values for R1, R2 and R3. Let it be some 3 ohm, R2 5 ohm, and let's say this is 2 ohm. Right? In Thevenin's theorem, the first step usually is to find RTH. Okay, and the concept was such that to find RTH we need to disconnect the load. Okay, R3 is our load, which is 2 ohm. Okay, R2, which is 5 ohm, R1, which is 3 ohm, and we have one voltage source. Okay, plus or minus 12 volt. Okay, so to find RTH we need to disconnect the load. Okay, so let's disconnect the load. Okay, and mark this port something like A and B. Okay, and we have to short circuit the source, voltage source. Okay, so this is the steps to find the RTH. So we'll find what is the resistance in from this point or port A and B. Okay, so it is very simple. It is the parallel combination of R1 and R2. So RTH equal to R2 R1 plus R2. Okay, R2 is 5 ohm and R1 is 3 ohm. So plug in these values. R2 is 5, 3 plus 5. So it comes around 0.625. Okay, 0.625 ohm. Okay, so we have calculated RTH. Now the second step is to find the open circuit voltage. Okay, or Thevenin's equivalent voltage. So what is the step to find VTH? We have to disconnect the load. Okay, so this is R1, R2, R1. Sorry, this is the input voltage source, 12 volt, and we had a load in this port. Okay, if you see the original circuit here, R3. So disconnect this R3 and we'll see what is the voltage across this port A and B. Okay, which we'll call as VTH. So VTH equal to I think I made mistake here, sorry. In parallel combination it is supposed to be R1 into R2. Okay, please pardon me. So R1 is 3 ohm. Okay, there is some slight correction here. This should be 15 by 8, which is 1.8 ohm. Okay, pardon me. So VTH equal to, this is simple, this is a simple voltage divided circuit, so R2 divided by R1 plus R2 into input voltage. Okay, so substitute the values. R2 we had 5 ohm, 3 plus 5 into 12, so it is around 7.5 volt. Okay, so now we can have our Thevenin's equivalent circuit of 7.5 volt. Okay, this is VTH. in series with RTH equal to 1.8 ohm. Reconnect the load, which was R3 equal to 2 ohm. Now we'll calculate the current in this circuit. What is I here? I equal to apply Ohm's law, VTH divided by RTH plus load resistance R3. Okay, so substitute the values: 7.5, 1.8 plus 2, 1.97 ampere. Now we will verify this in our LTSpice software. So let us create the circuit schematic in LTSpice. So we have one voltage source, resistance R1, R2 and R3. Connect the terminals, put some ground. So we had R1 as 3 ohm, R2 was 5 ohm, and load resistance R3 was 2 ohm. Okay, and input voltage is 12 volt. Okay, so this was the given circuit, and after applying Thevenin's theorem, we got VTH of 7.5 volt and RTH was 1.8 ohm, and load resistance, it is same. Okay, it is same as R3, which is 2 ohm. Okay, this R3 and R5, they are the load resistance. So this is our Thevenin's equivalent circuit, this one. And since Thevenin's theorem says that these both circuits are equivalent, we want to see whether the current flowing through R3 resistor is same with R5 or not. Okay, so run the schematic, maybe 3 minutes. So if I probe the current across the original circuit through R3, I get approx 1.9 ampere current. Okay, this is R3. And let's see what's happening here in Thevenin's equivalent circuit. If I probe current here, this is R5. If I click R5, I get 1.9 ampere current. Okay, so basically they are same. So Thevenin's theorem works.